Hello everybody. In today's class we are discussing about top-down parser. There are basically two kinds of top-down parsers. The first one is called as recursive descent parsing and the second one is called as a predictive parsing. The recursive descent parsing is basically a backtracking kind of parser, nothing but a trial and error method. It is the general parsing technique but not widely used method, which is why it is a not efficient one. So other kind is a predictive parsing method, which is not having any backtracking over here, which is why it is a efficient method which needs a special form of grammars, LL1 grammar. Recursive predictive parsing is a special form of recursive descent parsing without backtracking. Non-recursive, or it is also called as table driven predictive parser, which is alternative name for LL1 parser. The first L here stands for left to right input are scanned. The second L stands for leftmost derivation that you are applying. 1 in the bracket indicating that you are looking ahead for one input symbol at a time while parsing. Okay. Moving on to quick introduction to recursive descent parsing, which makes use of a backtracking, which is trying to apply a leftmost derivation. Let us consider a production like this, where you have a second production here, which is of the form B produce BC or B. So there are two alternatives to choose when you want B. Okay, so if that is the case, what would be the situation when you apply recursive descent parsing? We will understand with an example. We want an input string to be generated as ABC. So for that, we apply the productions with the leftmost derivation. So when you apply from the starting symbol S, produce ABC, you are going to obtain up to here the tree. Okay, A, B, C. Now, afterwards, we want next input symbol, because the first A is getting matched with this input symbol A. So we need next symbol as B. So from that B, we need to generate a small b. So for that, we may choose the first production. Our parser may choose the first production. So in that case, it's going to produce BC. Now you are obtaining a complete tree. So when you do this, and when you traverse through all this terminals, it's going to produce A, B, C, C. That is what a string to be will be generated by this derivation step. But our input symbol is not this, right? Both are not equal. Therefore, this test fails and you need to backtrack. So when you backtrack here to B, and from B again you choose alternative production called B produce B small b. So when you do that, so your string is ABC. Your string is ABC. Therefore, it is matching to our input string. So like this, you are going to apply trial and error method, which is also called as a backtracking, and it is a recursive descent. That's why this is not a most efficient technique, and it is not being used by many other methods. Moving on to non-recursive predictive parsing, which is also called as LL1 parser, which is a table driven parser, and it is also using a top-down approach, and it is also called as LL1 parser, as I said earlier, which makes use of several components, that is input buffer. Your non-recursive predictive parser algorithm makes use of an input buffer, and you have a two-dimensional connection with a stack, and also parsing table is being used here in order to obtain the output. Let us quickly see what are the components of LL1 in detail. There is an input buffer, output, a stack, then parsing table. Okay. So what is that input buffer? Our string to be parsed will be stored in the input buffer. So we will assume that its end marker is a special symbol called $. So for example, if you are giving a input string ABC, that should end with $. So what is meant by output here is a production rule. that is representing a set of derivation sequence, that is leftmost derivation that you are applying of the string in the input buffer. Next is a stack. Stack contains the grammar symbol. All the grammar symbol will be there in the stack. At the bottom of the stack there is a special symbol called a dollar again here, indicating that it is an empty stack. Initially stack contains only a dollar and a starting symbol S. Say in this case capital S is a starting symbol. If any other non-terminal is being used as a starting symbol, that can be placed like this, dollar followed by a non-terminal, that is a starting symbol. This is called as an initial stack representation. When the stack is emptied, after processing your input, when stack becomes empty, only left with the dollar symbol, that is the indication of parsing has been completed. The last one is a parsing table, which is a two-dimensional array which is represented in the form of capital M, where first parameter is a capital A and second parameter is a small a. So this is nothing but M matrix of A is a non-terminal upon small letter a, that is terminal. So what is an entry, what production is being stored, A upon A. So that is what a parsing table holds. Each row here, while constructing this matrix, your row values to be filled with the non-terminal and the column values are filled with the terminals. Say if there is a T1 terminal 1, terminal 2 and so on. So you need to make a column for that. Finally dollar also. Dollar should be the last column. Now here for every non-terminal upon a terminal, what is that production, you are going to write it here. So every entry here holds the production rules. So this is being computed with the help of first set and follow set computation, that you will understand in the next class. The first set to be computed and also follow set to be computed in order to complete the table entries. Okay, so there are two functions, major functions for construction of LL1 parsing table, first and follow. So rules for these two can be discussed along with the problem later stage. And after constructing that first and follow, we need to do some actions for passing the string. For that, we have to make use of the procedure like this. There are 4 possible parser actions to be taken. So let us see individually what is that. So first let us understand what is X and A. The symbol on top of the stack is say capital X and the current symbol on the input is small a. In that case we will understand what are all the possible cases, and there are only 4 choices, 1, 2, 3 and 4 choices. Among this we are going to categorize them. If X and A both are only dollar, then it is a parser halt actions, nothing but a successful completion of the string. Okay. Next, second one is if X and A are the same terminal symbols other than dollar, there would be A on the stack, A on the input symbol. There would be B on the stack, B might be the input symbol. In that case both are getting matched, so you have to pop it out. So parser has to pop this, you have to pop them from the stack and as well as input symbol, you have to move ahead. If X is a non-terminal and A is a terminal, in that case a parser looking for a table entry, you have to look into the table which cell, this is the cell holds the production. Say for example production rule is of this form. In that case you have to pop X because X is there on the stack, pop the head of the production and push the body of the production into the stack. How do you push into the stack is in the reverse order. You have to look into this sequence. In the reverse order you are pushing into the stack. Next, the last case is none of the above case. So that means if it is not this case, not the case, not the case, then there would be an error. This last option is a error case. So what are all such errors is all empty entries in the parsing table are also called as an error. If X is a terminal symbol different from A, this is also an error case. That means there are still symbols left over in the buffer or left over on the stack. Both can be called as a error cases. Only these are the 4 actions can be considered while taking the parser actions. So this completes a brief introduction to LL1 parser and its methods. Now we can discuss problems on this later classes. Thank you.